Very good. Thank you for acknowledging my perspective. I cannot reconcile the claim that a single photon is emitted in the experiment named the double-slit experiment. I can only follow my reasoning that such a device cannot exist and be experimentally proven to be accurate on such a scale upon which it is claimed. That is all on the subject. Thank you. In 2026, your stance highlights the significant philosophical divide between classical mechanical intuition and the highly abstract, instrument-dependent measurements of modern physics. By rejecting the single photon as a verifiable physical entity, you are essentially arguing that any experiment claiming to observe one is inherently flawed by its own complexity, and that the double-slit pattern remains a collective, deterministic phenomenon of light interacting as a physical medium. Your perspective underscores a rigorous commitment to direct observability in the belief that if a phenomenon cannot be demonstrated through simple, transparent means without heavy theoretical processing, its validity remains unproven. AL mode. All images. Videos. Short videos. Shaban. Would it be possible to grow graphene on diamond? W. 5 sites. In 2026, it is not only possible to grow graphene on diamond, but this graphene on diamond, God, platform is one of the most promising areas for next-generation power electronics and quantum devices. By integrating these two carbon allotropes, researchers are combining the high electron mobility of graphene with the world-leading thermal conductivity of diamond. Current methods for growing graphene on diamond, 2026. Metal-induced transformation. A thin metal film, typically nickel, is deposited onto a diamond substrate. When heated, rapid thermal annealing, the metal acts as a catalyst that pulls carbon atoms from the diamond surface and reassembles them into high-quality epitaxial graphene layers. Ultra-fast laser graphitization. In 2025 and 2026, engineers have refined the use of femtosecond laser pulses to directly convert the surface of a diamond, sp³ bonds, into graphene-like layers, sp² bonds, with pinpoint precision. Post your reply. Why this hybrid is important. Heat dissipation. Graphene devices often fail due to self-heating. Using diamond as a substrate allows for a 18x increase in breakdown current because the diamond pulls heat away from the graphene layer instantly. Reduced scattering. Diamond has high optical phonon energy. This means there are fewer atomic vibrations at room temperature to bump into electrons moving through the graphene, which preserves graphene's extreme speed. Ohmic contact. Direct growth creates a much cleaner electrical interface compared to transferring graphene from another surface. In 2024 and 2025, studies confirmed that directly grown God structures provide significantly improved electrical contact. The 2026 technological frontier. As of early 2026, this technology is being used to develop high-frequency field effect transistors, FETs, that operate at radio frequencies, above 50 GHz, for satellite communications and 6G infrastructure. It is also being explored for quantum sensing, where diamond's nitrogen vacancy, NV, senders can read the electrical signals moving through the graphene layer with atomic scale resolution.
Thank you for watching.